Hello and welcome back to our channel. Today we will be talking about another problem from the same paper as last time. So let's get started. A sequence of integers a1, a2, a3 is defined by a1 equals k and an plus 1 equals an plus 8n for all integers n greater than 1. This means that the first term is k, while the second term is k plus 8 and the third term is k plus 8 plus 16. We've been asked to find all values of k such that every term in the sequence, that is, all of a1, a2 and a3, are squares. We're going to do this in 3 different ways, so let's get started. From the definition above, we can see that a2 equals a1 plus 8 when n equals 1. Since a2 and a1 must both be square numbers, we therefore have 8 equals a2 minus a1, which equals y squared minus x squared. We can do this because a2 and a1 can both be written as square numbers, where x and y are natural numbers, that is, counting numbers. By the difference of two squares, we have 8 equals y minus x multiplied by y plus x. Now, we should note that both x and y are positive, so y minus x is always going to be smaller than y plus x. This might not seem particularly important, but it will help us reduce the number of cases we have to consider later. Now let's consider the number of factors 8 has. It has 2 pairs of factors, 1 and 8 and 2 and 4. Now, y minus x equals 1 and y plus x equals 8 is not possible for integers. However, y minus x equals 2 and y plus x equals 4 gives y equals 3 and x equals 1. Therefore, a1 equals x squared, so x squared equals k equals 1 squared equals 1. And that is the first solution done. Now, let's look at the second solution. We'll start by listing square numbers up to 25. Why we're doing it up to 25 will become obvious later. Now, the square numbers are 1, 4, 9, 16 and 25. And their differences are 3, 5, 7 and 9. If we draw a line here, we can see that on the left, the differences are all smaller than 8, whilst on the right, the differences are all larger than 8. This means that the square numbers on the left can be a1 or a2, whilst any numbers to the right of the line cannot be any of a1 or a2. If we consider the differences between any two squares, we find that the only pair of squares 8 apart is 1 and 9. Therefore, a1 equals 1 equals k, and a2 equals 9. It's not hard to test that this works for small numbers, however we now need to prove that this works for all numbers. I'll do most of the following section in blue for reference during the third solution. From the definition above, we have an equals 8 of n minus 1 plus a n minus 1. I've written it in this format so that we can simplify it later. Of course, similarly, we have an minus 1 equals 8 of n minus 2 plus an minus 2. If we substitute this back into the original an formula, we have an equals 8 of n minus 1 plus 8 of n minus 2 plus a n minus 2. We could continue this pattern, but it's easy to see where this is going. So I'm going to simplify it and say that an equals 8 of n minus 1 plus n minus 2 plus all the way to plus 1 plus a1, which is of course k. Since we know that k equals 1, we can simplify this to 1 plus 8 of 1 plus 2 plus all the way to n minus 1. We now need to simplify this large bracket on the end. Using Gauss's summation formula, we find that there are n minus 1 different numbers. So, by the formula, we have 1 plus n minus 1 all together multiplied by n minus 1 all together over 2 is the sum. We can simplify this to n minus 1 all over 2. Substituting back, we have an equals 1 plus 8n multiplied by n minus 1 over 2. This is 1 plus 4n of n minus 1. If we multiply the 4n into the brackets, we will end up with 4n squared minus 4n plus 1. This can be written as 2n minus 1 all squared, which is a perfect square, and therefore an is always a square. Now let's look at the third solution. From the blue section just above, which is all of this stuff, we have an equals 4n squared plus 4n plus k for any generic k. If we complete the square on this, we get 2n minus 1 all squared plus k minus 1. Now, if an is always square, then we have infinite pairs of square numbers with a difference of k minus 1. However, if k minus 1 is larger than 0, this cannot happen since the difference between consecutive squares increases, meaning it will eventually increase past k plus 1. Therefore, k minus 1 is 0, so we have k equals 1, and that's the solution. Thanks for watching, and if you liked our solution, please like and subscribe, and we'll see you next time.